In this video, we'll be introducing the slope of the tangent line. Recall the slope of the secant line is defined to be the change in y divided by the change in x, that is f of x1 minus f of x0 divided by x1 minus x2. Well, x1 is simply a little bit away from x sub 0, so we can replace x1 with x sub 0 plus h. See, if I put it on the number line here, if this is our x sub 0 right here, and then x sub 1's here, there's a distance of h in between them, so we could call x1 this x sub 0 plus h. And we can do the same thing in the denominator, so this will simplify that the slope of the secant line is f of x sub 0 plus h minus f of x sub 0 all over h, where of course h is not equal to 0. And if h was 0, that doesn't really make sense, because then the 2 points would be on top of each other if there was no distance in between them. So let's find the slope of the secant line given f of x equals 5 minus x squared, where x sub 0 is equal to 2 and h is equal to 1. So we're just plugging into that formula I have highlighted there in green. F of x sub 0 plus h minus f of x sub 0 all over h. Let's plug in. We know x sub 0 and we know h, so we're looking at f of 2 plus 1 minus f of 2 all over h. So here we have 5 minus 2 plus 1 squared minus, put this in parentheses here, 5 minus 2 squared all over 1. Let's clean this up. It's going to be 5 minus 3 squared minus 5 minus 4 all over 1. And really we can ditch that over 1. So it's 5 minus 9 minus 1. The slope of the secant line is equal to -5. The slope of the curve y equals f of x at the point x0, f of x0 is the number m, right, for slope. The limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 all over h, provided the limit exists. This number is also called the derivative. You are going to spend a majority of your time in calculus finding the derivative. The tangent line to the curve at P is the line through this point P with the slope that's equal to the derivative. So the derivative, which is the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 all over h, shows the slope of the tangent line, thus tells us how the function is changing. So I want to look at this diagram here and talk about why this makes sense. So we've already established that the slope of our secant line is this f of x sub 0 plus h minus f of x sub 0 all over h. So here's our first point, x sub 0. And then here's our second point that is a distance of h away from the first point. It says that we're going to take the limit as h approaches 0. So we're moving this second point closer and closer to the first one because we're making that h value, the distance in between the points, smaller and smaller. We're having it approach 0. So as we continue to shrink this distance, we see that the slope of the corresponding secant line is changing. And if we take this value h and have it approach 0, so it's getting as close to 0 as it possibly can without actually being 0, the first point and the second point essentially become one and the same. And so now this secant line is actually only grazing the graph one time. A secant line intersects a curve at 2 points, but a tangent line intersects a curve at a single point. So that's why if we take this slope of a secant line, but have the limit as h approach 0, it turns into the tangent line, because the first and the second point are so close together that they're practically the same point, and our secant line ends up hitting the curve a single time and it becomes a tangent line. And this gives us the slope of the curve, or our instantaneous rate of change, which is, well, pretty much everything we do in Calc 1. You'll notice that this is essentially the difference quotient. The only difference is a sub-zero, right? If we take this out, there's our difference quotient, f of x plus h minus f of x all over h. We're taking the limit as h approaches 0 of our difference quotient. So we found the slope of this function secant line at x sub 0 equal to 2 when h was equal to 1, but now we want to find the slope of the graph at x sub 0 equals 2. To find the slope of the graph, we need to find the slope of the tangent line, and the slope of our tangent line is our derivative. So the slope of our tangent, we're using the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 all over h. So m is going to be the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Let's plug that into our function. The limit as h approaches 0 of 5 minus 2 plus h squared minus 5 minus x squared. Oh, I'm plugging 2 in for x. 2 squared all over h. Well, let's clean up this numerator, and just like when we were finding the difference quotient in college algebra, we are going to do simplification until that factor of h in the denominator cancels out. We get the limit as h approaches 0. Now here in the numerator, you're going to have to write that twice and multiply it out, or hopefully by now you're getting comfortable with the shortcut, squaring a binomial, where we get the first one squared plus twice the product of the two terms plus the second one squared. Now I have to keep this in parentheses because I'm subtracting the result of this product, so I'm going to have to ultimately distribute this negative. We get 4 plus 4h plus h squared, and then minus 5 minus 4 all over h. This is the limit as h approaches 0. 5 minus 4 minus 4h minus h squared minus 1 all over h. We'll combine some like terms here. See, we got these constants, 5 minus 4 minus 1. Well, those just cancel out. we're going to get the limit as h approaches 0 of negative 4h minus h squared all over h. I can't plug 0 in for h right now because it'll give me a 0 in the denominator, an expression that's undefined. So instead, we'll factor an h out of the numerator. And once we're in factored form, we can cancel these two h's out. The limit as h approaches 0 of negative 4 minus h, we're going to get the slope of the tangent line being equal to negative 4. In part B, we want to find the equation of the tangent line at x equals 2. In order to write the equation of a tangent line, we need, well, of any line, we need two things. We need a point and the slope. We found the slope in part A to be negative 4, and now we need a point. They gave us the x value. We'll find the corresponding y value by simply plugging into our function. So we're finding f of 2. So we get 1. We're writing the equation of the line having a slope of negative 4 passing through the point 2, 1. I like to use point-slope form of a line to write my equations. Y minus y1 equals m times x minus x1. So that's y minus 1 equals negative 4 times x minus 2. We'll just clean this up and put it in slope-intercept form. The slope, or the equation of our tangent line at x equals 2 is going to be y equals negative 4x plus 9. So here's a continuation. Part C, we want to find the slope of the graph at x sub 0 equals 0. So we're basically just doing a repeat of parts A, but this time we're doing it when x sub 0 is equal to 0. It's going to be the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. This is the limit as h approaches 0 of 5 minus 0 plus h squared minus 5 minus 0 squared all over h. So limit as h approaches 0. Now this here is just going to simplify to be h squared. So 5 minus h squared, and then 5 minus 0 squared, of course, is just 5 all over h. So the limit as h approaches 0. Combining like terms, we see that our constants fall out, leaving us with negative h squared over h. Simplifying, we get the limit as h approaches 0 of negative h. Now we can plug our 0 in for h, and we get that the slope is equal to negative 0, which is just 0. In part D, we want to find the equation of the tangent line at x equals 0. So this is just like our part B. In order to write the equation of a line, we have to have two things. We have to have a slope, which we have, and a point. Well, we have the x-coordinate, but to find the corresponding y-coordinate, we're going to plug into our function, and we get the y-coordinate to be 0. A slope of 0 means that we have a horizontal line. Horizontal lines are always y equals a number, and the number we're going through is 5. We get y equals 5.